Welcome to the session on conditional probability, probability formulae. The objectives for this session are to use probability formulae to solve problems. We're going to use a Venn diagram to construct probability formulae. Consider the Venn diagram shown. If probability of A equals A, probability of B equals B, and probability of A intersect B equals P, then we can place these as shown. So here's the probability of A equals A. Here's the probability of B, which equals B. And here's the probability of A intersect B, which equals P, as shown here. And so using this information, we can express our probabilities as shown. The probability of A, excluding the B region, is equal to A minus P. The probability of A intersect B is equal to P, as you can see here. And the probability of B, removing the probability of A part, is equal to B minus P. Given this diagram, we can see that probability of A union B equals A minus P plus B minus P. And tidying this up gives us that the probability of A union B equals A plus B minus P. And therefore we have the following addition formula for events A and B. Probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B. Now let's apply this formula to an example. Pause the video and have a go. Press play when you're ready to view the solutions. Do note that we do not know whether A and B are independent, therefore we cannot use the formula probability of A intersect B equals probability of A times probability of B. Let's take a look at this example. For events A and B with probability of A equals 0.5, probability of B equals 0.8, and probability of A union B equals 0.7, we're required to find the probability of A intersect B. So let's solve this. Notice that the additional formula states probability of A union B equals probability of A plus probability of B minus probability of A intersect B. So let's plug in all the values. We have probability of A union B equals 0.7, probability of A equals 0.5, probability of B equals 0.8, and now we can find probability of A intersect B. So rearranging this gives us that the probability of A intersect B equals 0.6. We're going to use the Venn diagram again to help us construct another probability formula. In order to find probability of B given A, we need to restrict the sample space S to the set of outcomes in which A has already taken place. So, to find probability of B given A, let's restrict as shown. And so we have probability of B given A equals P divided by A minus P plus P, which is equal to P divided by A. And this equals probability of B intersect A divided by the probability of A. And so we have our formula for probability of B given A. This is called the multiplication formula, and we can rearrange this as shown. Let's now apply this formula to an example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. Suppose that events A and B are such that probability of A equals 0.4, probability of B equals 0.7, and probability of A given B equals 0.5. We are required to find the probability of A intersect B. So let's take a look at this more closely. In our formula, we have probability of B given A. However, in the example, we have probability of A given B. So you can see that all we need to do in order to get the formula for probability of A given B is switch the A's and the B's around in our formula, giving us this formula. Notice that the A and the B have been switched around. So let's solve this. We're going to use this multiplication formula and plug in the required values. So probability of A given B equals 0.5, probability of B equals 0.7, and carrying out this multiplication gives us that the probability of A intersect B equals 0.35. And now for part B. We are required to find probability of B given A. So let's solve this. We're going to use this formula highlighted here. From part A, we have that the probability of A intersect B equals 0.35, so we can plug that in as shown. And we have that the probability of A equals 0.4, so we plug that in. And dividing, as shown, gives us that the probability of B given A equals 0.875. Now let's solve part C. We're required to find the probability of A union B, so we are now going to use the addition formula. Now from part A, we have that the probability of A intersect B equals 0.35, and therefore plugging in everything into the addition formula gives us probability of A, which is 0.4, plus the probability of B, which is 0.7, minus the probability of A intersect B, which is 0.35. And calculating this gives us that the probability of A union B equals 0.75. This brings us to the end of this session. If you have understood its contents, you should be able to use probability formulae to solve problems. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.